Alrighty, friends of the LeetCodes. So we're going to look at problem number 36, valid Sudoku. I hope you know what a Sudoku is. Otherwise, you need to Google that. So the task is to determine if a 9x9 Sudoku board is valid. And only the filled set need to be validated according to the following rules. And this is what a Sudoku is, right? Each row must contain the digits 0 to 9 without repetition. So if we look at this row, 6 must only appear once, 8 only once, and 9 only once. We don't care about the empty spaces. And the same is true for the columns. So if we look at the column, we must not see any repeating digits in each individual column. Then also each 3x3 subboxes, so this is the first subbox, second and the third, of the grid must contain the digits 0 to 9 without repetition. Of course, we're going to ignore empty cells because of that's how the problem works. Yeah, so in each square or cell, I like to call them cells, we cannot see any repeating digits. Okay, some notes. A Sudoku board that is partially filled could be valid, but it's not necessarily solvable. Okay, that's fine. Only the filled set need to be validated according to the mentioned rules. Let's see what else we have here. Constraints, board length is 9. So this is the height of the board. This is the width of the board. And at each position of the board, we have a digit or a dot representing that there is no digit entry here. So that is something we can ignore then if there's a dot. Cool. So for the runtime and space complexity, I can already tell you it's O of 1 because the board is of fixed size. But of course, we're going to pretend that the board has length and width of n so that we can perform a runtime analysis. And I actually got this once in an interview. And it's actually, well, I got a variation of this in an interview, not exactly this one. But it's really easy if you've done it once. It's hard to forget as well. So basically what we need to do is we just need to, well, collect all the digits in the rows, all in the columns, and all in the boxes. And then we just make sure that there are no duplicates. And if we see any, then we know it's not a valid Sudoku board. So yes, we're going to have 3 data structures. One for the rows. And it's, oh yeah, we need to have a dictionary, right? And the dictionary will contain sets. So we have, because we have 9 rows, we will have 9 entries in our rows. And in each, we will have a set of the digits that are in that row. And we keep adding digits. And if we see that a digit was in there before, we know it's not a valid Sudoku. And then we do the same for the rows. Let's do that. And actually, I'm going to use a default dict just to make it easier so I don't have to take care of the initialization. And in LeetCode, you don't have to import it, I think, but I always do that because even in an interview, I would also do that just to make sure that I don't get it wrong. So we have the rows, we have the columns, and now we need to have these boxes, or as I like to call it, them cells. And it's the same thing. Right. We just have to then compute, in which cell are we currently. Easy to iterate over the rows and the columns, but how do we iterate over the cells, right? So yeah, that's what we will do. Now we're going to iterate over all of the cells in the board. So I like to do that with an X value in range width of the Sudoku board. And for Y in range height. And if you like, it doesn't matter. It's a matter of taste in which order you do that. Let's go row by row. So the inner loop will be the row and the outer loop will be, well, The inner loop will loop over the columns, the outer loop will loop over the rows. Right, so, and to get the width and the height, we know they're the same, but, you know, so we get the length of the board for the height. Oop. And if we want the width, we just take the first index, the first row of the board to get the width of the board. Yeah. We can do it like that. We can also just do it like this. Maybe let's do it like this. Or even better, we just call it n. N, because we know it's an n by n Sudoku. Cool. So now the value at that position is board yx. So first the first index is the row and the second is the column. So that's the value. So now we need to add this to our rows and our columns. So rows, in which row are we? In row number y, we're going to add the value. But first we have to check whether the value already exists in that row. If, well, in row y, you return false because which value already exists in that row? It shouldn't, right? So that's what we'll do here. And we'll do the same for the column, false. But here we do x, right? And if the check passes, false x at val. And now if val in cells, I don't know. We have to compute this z. Return false, and otherwise we do cells z at val. So we have to compute the z. Well, how do we compute the z, right? So z, depends on the value of x and on the value of y, right? And one way to compute this is we take the value of x, make an integer division by 3. That would tell us in which cell we are in this cell row. So if x is 0, 1, 2, integer division by 3 will return 0. If x is between 4, 5, 6, integer division by 3 will return 1. So with this, we can iterate over the cells in a cell row, but we also have to take account, well, we also have to figure out in which cell column we are. So if y is, for example, between 0 and up to 2, we are in the 0th row of the cells. But if y is between 4, 5, 6, then we basically have to, well, we are then in the second cell row with a 0 offset, so then it's then 1. But so what we have to do is we have to add the y value with the integer division by b. Yes. So let's make a small test here to see if that logic works out. If we have this cell, so that's x2 and y2. So this will be 0, this will be 0. Yes, so the 8 is in cell 0. If we go here, let's say this position, the 2 is at position x 0, 1, 2, 3, 4, and y 0, 1, 2, 3, 4, 5. So x4 divided by 3 is 1, plus y divided by 3 is also 1. So we have 3 plus 1 is 4. So this the 2 would be in cell 4. And that is correct. This is cell 0, cell 1, cell 2, cell 3, cell 4. So I think that should work out. And finally, after we do all this iteration, we return true because we didn't find any contradiction that things should be different. And one more thing, the value if the value is a dot, right, we should ignore it. So we just continue it. We just continue. And these values are also string values, as you can see, but it doesn't really matter for our purposes here. We can just put them in here. It doesn't matter if they're strings or numbers. Point. So if I run this, so this will work. Let me just add the runtime complexity. So this will be O of n times n, so it's n squared. And we will have a space complexity that is also dependent on how many values are actually set in the Sudoku. And in the worst case, they're all set. And so time and space complexity are the same here. Just going to submit this to make sure that it works fully. Yeah, so that actually works. And now there's some people out there who go a little bit ham. So there is a way to reduce the space complexity to O of n, but I'm not going to do this. But the way you do this is because you can do this by encoding these data sets with a bitmask, right? If you know that the 9 occurs in this row, you could just set the 9th bit of the number that represents that row. So so you can actually encode, you know, these digits in in a binary number, and then you only have to check if the value and let's say the bit mask that represents that row is unequal to 0. That means you have to return false because that bit at that position was already set. So that's another optimization that you could do. It would bring down the space complexity to n, or technically n log n, because you also need space to store the log n long binary number. But yeah, some people do that. Sometimes you see that. I don't really know if that's necessary to do. Might be useful to mention that in an interview, but yeah, it's I don't know. I don't know if that really moves the needle a lot if you implement that as well. No clue. But anyways, that's this problem.